Hey, so I'm going to show you two examples for how to graph these piecewise functions on Delta Math. So this first equation is x plus 5. That means that the function or the line would have a y-intercept of 5. It would have a slope of 1. And so what that means is you're going to go to the 5 on the y-axis and you're going to click to make a dot, but you just click and hold. And then you're going to go up 1 over 1 to make the slope. So it's going to make a little line segment like that. If I were you, I would keep going up 1 over 1 a few times to extend the line as far as you can. And I'm actually going to go down 1, left 1, kind of reverse it to make the line go in the other direction too. Make sure it's a straight line. Hold on. Okay, so once you do that, I feel like this one's not straight. Hold on a second. If you do what I did and you mess up and you realize you want to fix it, you can click the line and it'll delete it. So I'm going to try this again. Up 1 over 1, up 1 over 1. Let me do it a couple more times. Okay, that looks better. Now, what I'm going to do is probably jot down on paper where these endpoints are located so that I know where I need to continue my line after I look at my restriction. Okay, so here's the thing. This line only exists when x is less than or equal to -4. So here is where x is -4. So basically only the part of the line that's to the left of this is going to exist, which means everything to the right of that is going to go away. Okay, so I'm going to make a note of where the line hits at -4, which it hits at 1. So -4, 1. I'm going to delete all this other stuff. And I know that my line is going to continue starting at -4, 1. So I'm going to click and hold, go repeat the slope, which is 1 over 1. But since I'm going backwards, it would be down 1, left 1. Do that a couple times and let go. And then I'm going to look at the type of circle I need. So for this one, it says less than or equal to. So that means at -4, I would like that to be a filled in circle, which it already is. This also says that x is going to exist everywhere less than -4. So I would want this last endpoint here to be an arrow. So if I click the endpoint, it'll change, and I'm just going to continue until I get the arrow. For the second part, the equation is just 3. That means you have a horizontal line that goes through the y-intercept of 3. So it'd be like this. Okay? I'm going to just draw the line kind of, I don't know, kind of long-ish, and then I'm going to look at the restrictions and see which part of it I want to keep. So this says the line only exists when x is greater than 3, and so you're going to find where x is 3, go up, and that's where the line's going to actually begin. Now see how the arrow is pointing to the right? That means your line will be pointing to the right. So I'm going to go up to 3, which is at 3, 3. I'm going to make a mental note or jot down that this line's going to start at 3, 3. And then I'm going to delete this one. And I want to start a new one. So I'm going to go to 3, 3. I'm going to click and drag over a little bit until I have a line segment. Then I'm going to go back and I'm going to check the endpoints. So at 3, this time up here in the symbol, it says it does not say equal to 3. So we would want this endpoint that's at x equals 3 to be an open circle. So I'm going to click that and it'll change it to an open circle. On the end, it does say that x can be anything larger than 3. So that means it should continue on forever in this direction. I'm going to click this endpoint twice and to get me an arrow. So that should be it. Let's hope that this works. All right, good. So let's try one more. Maybe one that is a little bit more challenging. Okay, here's a good one. So this time I'm going to start at the top. I have a y-intercept of -1 and a slope of -1. So I would start at -1 on the y-axis and I would go down 1 over 1. I'm going to do that a few times. And then I might even do that in reverse. Continue the line in that direction. So I've got more data points. Now, look at your restriction. It says this line will only exist when x is less than or equal to -4. So you go to -4 on the x-axis. you go up and you make a mental note of what this ordered pair would be. Okay, that's going to be like your starting point. So that is -4, 3. Okay, and it says x is only anything less than that. So that means my line is going to start here and it's going to go to the left. Okay, so I want to make sure that before I delete this, that I write down that my new line is going to start at -4, 3, and it's going to have a slope of left 1, up 1, or down 1/1. So now I can delete these lines by clicking on the line. I'm going to go to -4, 3, click and hold, drag it over to make my slope. Just do that a few times. And then you're going to do what we did before and check for endpoints and see if you need to change them. So this one does have an equal to sign, which means I need a filled in circle when x is -4. And it says x exists anywhere left of that. So I do want this to continue forever to the left. So I need an arrow. So I would click that endpoint 2 times. All right, last part. So this one we're starting at 7 on the y-axis, and we are going up 3/1, which I don't have a lot of room on this side. So I'm going to go in reverse, which would be down 3, left 1, down 3, left 1, like that. And then I'm going to look at my restriction. So my restriction says only when x is greater than -1. So find -1 on the x-axis, go up and make a note of where this point is, because that's going to be your starting point, and it is -1, 4. Get rid of these, go to that point, and you're still doing the same slope, up 3/1, up 3/1, like that. And then you're going to change your ordered or your points to either open circles, closed circles, or arrows. So at -1, there is no equal to sign. So you need an open circle. And it does say the line will continue to the right of -1 because the arrow is pointing to the right. So I want an arrow on the right side of that line segment. There you go. Hopefully this helps.